Hey guys, back at it again. Totally messed this whole part up. I wasn't even paying attention to what I was writing, so we'll get to that here in a second. So if we look at this, we know that the middle's right here. And so how far are the values from the mean on average? Well, if we look at it, we've got these marks to the side and these marks to the left side, and the middle is 2, so that's probably going to be the mean. But if you wanted to figure out the average, 1 is 3 away from 4, 2 is 2 away from 4, but there's 2 of them, and 3 is 1 away from 4. So if we add that side up, that's 8. This is 8 on this side, so 8 divided by a total of 16 divided by a total of 8 data points is 2. So if I get a value of 2, they're 2 away from the mean on average. So that's really what the standard deviation measures. It's the average distance from the mean value for all the observations. So if we get a bunch of data points, we're just calculating the average distance from the mean value. So if I'm going to calculate the average standard deviation, so one of the formulas you'll see is something like this, which is the population, or you'll see the standard deviation of x, which is the sample. So they really mean the same thing. It just depends on what we're dealing with right there. So the book gives you a little bit different idea where it says s squared of x equals, and then it has this huge x1 minus x bar squared plus x2 minus x bar squared plus, and then it just goes dot, 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 and then it has n minus 1, right? So what we're saying is that you'd take x minus x bar, so your x value, minus the mean you found, you subtract them, and then you'd square it, and then you'd add that to the second data point, x squared minus x bar squared, and you just keep going and going and going, and then you'd finally divide that by n minus 1. So this thing looks a little bit ugly, but you'll also see it in a little different form. If we took the square root of both sides, we get a little different piece to it, which is going to be the standard deviation of x is equal to the square root of the sums of x, there's a little I there, of all the x's minus x bar squared over n minus 1. Okay? So we end up with that little piece here. And don't forget to take the square root of that whole thing. All right? So we sum all those together, add them all together, divide by n minus 1, and then we have the standard deviation. So we'll work with that. Again, the calculator finds it all for you. The variance is all of the squared values. So the variance is the average squared distance. This is the average squared distance. So the larger the squared distance, the larger the standard deviation. Let me slide this up a little bit. The paper's getting stuck. So what are the similarities and differences between the range and IQR and standard deviation? Don't forget, range is max minus min. IQR is Q3 minus Q1. And this is non-resistant. And it's just one huge range. This is resistant, and it's the middle 50%. And then your standard deviation is the formula you have there. It is not resistant, so big numbers will mess with it, just like mean. It's not resistant, and it is the average distance from the mean. All right. So how is the average, how is the the standard deviation calculated for the sample? We just kind of went over it on the prior page a little bit there. This is your standard deviation, and it's the sum of x is minus x bar squared all over n minus 1. What are some of the properties of standard deviation? Some of the properties include that it's the spread about the mean. It's always greater than 1. So there is no not 1, 0. It's always greater than 0. There's never a negative value. It has the same units as x bar. Okay? Has the same units as x bar. And again, it's not resistant. Resistant. So you can calculate this piece here. You'll find your mean, and then you'll plug it into that formula, and then calculate and interpret that. I will deal with that later because we're a little stretched on time right now. Let's see what we got. Okay, so I want to get to this, and if I have time, I'll go back to the alternate example. So what factors, oops, too far up there. What factors should you consider when choosing summary statistics? We've talked about this. Shape. Skewed. So if we're going to go 5-number summary and IQR, they're skewed. And if it's symmetrical or normal, we are using X bar and standard deviation. Okay? So that's from, so we've got to look at our shape first and kind of see what's going on. So let's look at this here real quick. If we're going to calculate standard deviation, if we're just going to calculate standard deviation, we're going to say, okay, we have a sample of 5 random students. Let me see if I have this problem or it's just one that I made up. I think it's just one that I made up. Yeah, it is. All right. If I have 5 random students, and this is how many hours did they spend doing their homework. So I would plug it into my calculator real quick, is what I would do. And I would go to stat. I would go to stat. I would go to my first list. I would clear out my list. And then I'd go over and clear that one out. Oops. Clear that one out and hit enter. I'll go back in, and I've got 0, 25, 30, 60, 90. So then I would go back to stat. I'd go to calculate, one var stats, make sure it says list 1, and then hit enter, 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 all the way through. So there we go. So I've got my standard deviation of, oops, sorry, my X bar of 41. So my X bar is equal to 41. So let's show you guys how to do this by hand. So here's the standard deviation of X. I take the entire square root, and I go 0 minus 41 squared. plus 25 minus 41 squared plus 30 minus 41 squared plus, oops, yep, that's right, plus 60 minus 30 squared plus, gets long, woo, plus, oops, my lights just went off, 90 minus 41 squared, okay? And then that is over n, there's 5 students, 5 minus 1. So if we do all that math, it becomes this crazy number, right? So if we do all this math out like this, we're going to get approximately a standard deviation of 34.71 minutes spent doing homework. What does that mean? That means on average, students spend 34.71 minutes on homework. On average, students spend 34.71 minutes on homework above or below the mean of 41 minutes. That's one way to state it. Oh, you guys can't see that. I apologize. So standard deviation of x equals 34.71 minutes spent doing homework. That means on average, students spend 34.7 minutes on homework above or below the average mean of 41 minutes of homework. All right, guys. So that is standard deviation. Just a quick setup for you guys, and we'll see you soon.